Okay, welcome back. Today, as promised, we're going to go over stoichiometry, but this time, instead of just using moles, we're going to use grams. So, our favorite word, stoichiometry. I can spell it with grams. Okay, so I don't have any food problems for us to do, but I have a food analogy. Okay, so remember before we were baking cookies, and we could tell you how many cups of flour we had, and the recipe told you how many cups, how many cookies you could make with how many cups of flour, and we told you maybe how many teaspoons of salt, and the recipe told you how many teaspoons of salt was required for making a dozen cookies. But let's assume then this time what's changed, instead of teaspoons and cups, maybe we say we only have 9 ounces of salt, or that we have 26 grams of flour. Then how many cookies could we make? Well, what we need to do is figure out how many cups does that 8 grams make if our recipe is in cups, for example, and how many teaspoons is in that 9 grams of salt. So we need the mass. We need to know the relative mass. So it's the same with stoichiometry, okay? So before, what we were doing was simply taking moles of one chemical. Might have been a reactant, might have been a product, who knows? And we were taking the coefficients in the reaction equation and using that molar ratio to determine how many moles of another chemical. So, simple enough. We're still doing that. We're not really changing that part. Okay? And we still need the chemical formula. So, let's put that down. Great. But what we're doing now first is we might have some mass to have to calculate and consider. So maybe we have a mass of the chemical first. And we need to transfer it to moles of the chemical. And how we do that, maybe you've done it before. It's just a conversion step, but it's using the mass, the relative mass of that chemical, and it's usually in grams per mole. Okay, so we're going to use the molar mass to go from grams to moles. And let's say if we want to go moles of the chemical that we're interested in, that we're trying to find, and we want to go to grams of that chemical, well, we'd also use the molar mass of that chemical as well. So if we want to say, well, I don't want to know how many dozens of cookies that we're going to make, I don't want to know how many grams of cookies. So I guess that would be the same type of conversion. It would just depend on which place, how you set it up. Okay, so we'll set that up for you. But here's our roadmap. Okay, and it's kind of like riding a train. You can't just start at the beginning of the train tracks and go straight to the end. You got to go through some towns along the way. Okay, so you don't know how many grams of cookies you're going to be able to bake if you only have 26 grams of flour. Okay, you're going to have to go through a couple conversion processes. Is this a 1, 2, 3 step process? Okay, so yeah, if you want to know mass, or if you want to know moles of a chemical, you would start at mass and go to moles of the chemical of that chemical, and then use the ratio from that formula, and then you'd get moles. Or you could take one step further and transfer it into and convert it into mass of that chemical. Maybe it doesn't make sense too well right now, but it will a little bit when we do it. Okay, so what we're gonna do is fermentation. Okay, well, not really. We're gonna talk about fermentation. Okay, I'm gonna try to fold that to make it a little smaller so you can see it up here. Okay, fermentation. It starts with sugar and actually glucose. Really, I mean, you might start out with a different sugar. But here's the reaction that we're looking at. we're going to make ethanol. Yay. Okay, so what we're going to do first is to kind of get glucose. You remember glucose? C6H12O6? Yeah, even if it started out with sugar, it'd have to be converted to glucose. Now, normally in the presence of oxygen, you'd be doing cellular respiration. Hence, byproducts would not be ethanol. It would be like water, CO2, okay? But in this case, the yeast, if you have the right kind of yeast under the right kind of conditions with no oxygen, it's going to be actually like a 3 or 4 step process with different enzymes that yeast has, and it's going to eventually transfer it to ethanol, which is C2H5OH. The reason why we don't group the H's together is because that OH group is just hanging there on the end, and that's how we traditionally write ethanol, so you kind of understand the structure, because it would be different than C2H6O. Okay, and another byproduct would be CO2. Okay, so first things first, we have to balance the equation in order to do any kind of conversions with this reaction. Okay, so kind of see some anomalies here, maybe right away. I'm seeing that there are 6 carbons here, but 2 here and 1 here. Honestly, just if you were looking at this, you probably wouldn't know how many carbons to make out of here and here, maybe right off the bat. So first, let's do something easier. Let's do maybe the hydrogens. Then we can adjust the oxygen and the carbons. So hydrogen, we start out with 12. And over here, we have 5 plus 1, so we have 6. So I'd say in order to get those to match, let's just put a 2 out front and double the amount of hydrogen. All right. Now we can see we have oxygen. We have 2 here and 2 here. We have 6. Okay, since we've already kind of adjusted this one, why don't we just add 2 more or multiply by 2 to make this 4 so that we now have the 6 and the 2 plus 4 matching. Okay, those match. We're good. We're happy. All right, did we take care of? Yeah, I see. Looks like we've taken care of the carbon already. So we had 6 over here, and since this is 4, and this is 2, we have 6 now. So we're all happy with the carbons and the hydrogens, and we don't need any more coefficients, right? We don't need to put anything in front of the glucose because the glucose is already written once, then you assume that coefficient is 1, okay? So you can resist the urge. This is the glucose, and this is ethanol, by the way. I don't know if you can see that. Okay. Well, let's find out how much ethanol we can produce. Let's find out first moles. Okay, we're only going to do part of the train ride. Let's find out how many moles of ethanol that we can produce with, let's say, 23 grams of glucose, right? With this reaction, if it was perfect, right? We'll say exactly 23 grams. I don't know. Okay, so we're looking for moles of ethanol, and we're starting out with grams of glucose. So always start out with what you have, right? Well, here we are in our little roadmap. We're given a mass of the chemical, and we're trying to find moles of a different chemical in the equation. So we need to take molar mass and transfer that mass of the chemical to moles of that chemical. Then we need to use the molar ratios to find out how many moles of the ethanol that's going to be. Okay, and then we stop and we get off the train there. Kind of make sense? All right. So we're going to start out with that 23 grams. I'm going to abbreviate here. And what we do is unit analysis, but we're going to link those 2 steps together to make it easy. That's why we're doing it this way and not using like our own mathematic formulas and then doing each step, because in the end, it's actually easier this way. So we have the glucose. What we need is the molar mass of the glucose. Okay, so how do we find molar mass? Well, you add them up. Literally, add them up. Get it? Right? Funny. Literally, what you need to do is take the individual masses of the atoms and take those into account of how many of each type of atom that you have in the molecule of glucose. Okay, so We do know from the periodic table that one atom of carbon weighs approximately 12 grams. I don't know if you can see that, 12 grams per 1 mole. But we have 6 carbons. Okay, so what we need to do is take 12 for the carbons. I'll just put a C for carbon. Multiply it by 6. You get 72 grams for 1 mole of those 6 sets of carbon. For hydrogen, now I don't have it in my periodic table, it didn't print out, so I couldn't see it, but I remember that it's 1 gram per mole, because hydrogen's pretty much just a proton that weighs 1 gram per mole. So let's do this, just to keep it consistent. It's weight is 1, and there's 12, and so we get 12, that's the contribution of those 12 hydrogens, okay? Now for oxygen, I can see here, we can round it, 15.9999 to 16. Okay, so 16 grams per 1 mole of oxygen, and we have 6 oxygens. So take that, 36, and we get 96. And I just add them up. And it conveniently adds up to exactly 180 because of rounding. And that's how many grams is 1 mole of glucose, because we're talking about glucose. Okay. Awesome sauce. So what we need to do here is put the 180 grams on bottom because we're trying to get rid of grams, and put the 1 mole on top. We're trying to get 2 moles. Remember, we go from the mass of the chemical to that moles of that chemical, number of moles. So the 180 goes on bottom of the grams of C6H12O6, and the 1 mole of the C6H12O6 goes on top. Okay, now if we finish that calculation, we would have moles of glucose, because that's the units we're left with. But we don't want to stop there. That's not our train stop. We're trying to go all the way to moles of ethanol. So we need the molar ratio from our equation of the coefficients of the glucose to ethanol. As you kind of can see here, 1 mole of glucose will produce 2 moles of ethanol. Okay, so we got to put that into our little equation right here. Put the moles of glucose, which happens to be 1, here, and then the moles of ethanol at the top, right? Cool. Now we can stop here because that's all we're calculating, and we're going to take the tops, multiply the tops, and then multiply the bottoms, and then you take the top divided by the bottom like you would in a fraction, right? So what we would get actually when we do this is 0.26 moles of ethanol. Okay. That's great. Now, what if we actually wanted to ride that train all the way to grams of ethanol? Okay. Then what we need to do is take the moles of ethanol and the molar mass of ethanol, how many grams per mole it weighs, and just do one more conversion to get that grams of ethanol, because we're always using grams. Remember, chemistry, we like grams. By the way, I rounded to 2 significant figures. That's the 2 and the 6. Because you were only given 2 significant figures in your data. And so, yeah, that works out. So what we can do is one of 2 things. We can just transfer the 0.26 moles of ethanol straight over. And then I'll show you one way we can do it to link it all together if we were doing it all together. Okay, sorry. So that's moles of ethanol. Molar mass, remember, we got to add them up. So remember, the carbons are 12 each, and there's 2, so that's 24. The hydrogens are 1 each, so there's 6 hydrogens here. That means 6 total from the hydrogen. The oxygen is 16, and there's only 1 oxygen. We only need to add it once, okay? So what do we get? We add that up, 46, right? Okay, and that's grams per 1 mole of ethanol. Cool. So what we're going to do is put the 1 mole on bottom here and the 46 on top, because we're trying to get to grams of ethanol. The moles of ethanol cancel out, and we get 46 times 0.26. All right, so we should get 11.8, or you have to round it to 12 because we only have 2 significant figures in this problem. Okay? And that's grams of ethanol. Awesome sauce. Okay, so 23 grams of glucose comes in, 12 grams of ethanol comes out. That's because we lost some weight with the carbon dioxide, right? Okay, so if we wanted to do this all together, let's say go from 23 grams of your glucose to the grams of ethanol, you could do that. Let me just slide this up just a little. I don't know, you probably can't see it all at once. That's okay. But here you could set it up. And you're like, but you already calculated it. And I'm like, well, if you have to do these all together, you're going to want to be able to link them. That's why we do this kind of math here. Okay, so if we did this conversion, we went from grams of glucose to moles of glucose, and then we're going to go moles of glucose with a molar ratio to moles of ethanol, and it's a 2-to-1 ratio, right? Oh, got to put moles. Got to remember where we're at, got to get the map, use the road map, and put your units down. So 46 grams of ethanol goes on top. Here, you can see it finally, sorry. 46 grams of ethanol per 1 mole. Okay, and you would take 23 times 2 times 46, which is a very large number, but then we divide it by the 180 because it's just 180 times 1 times 1. And we know we got the right units because all of these cancel out. And we're left with grams of ethanol, which is what we were looking for. And so you should get 12 grams of ethanol. So you don't have to be afraid of big calculations because we're just going to link them together, okay? So let's just do one more calculation with this reaction, okay? Let's find out how many grams it takes of glucose to do this in this reaction to form 46 grams of CO2. All right, let's try that. So we're still using the fermentation, same molar ratio, same chemical formula, and this time we are starting with 46 grams of CO2. Okay, and we're going to get on the grams to moles train again. That's up here. This time we're starting with grams of CO2, and we need to calculate how many moles that is, because then by the molar ratio, we can calculate how many moles of glucose that is. Then we can figure out how many grams of the glucose that was needed from the moles. Okay, so that's where we got to go through. Got to go through mole town and molar town and end up at Gramville or something like that. I don't know. Okay, so again, we need the molar mass. Okay, so we got to add them up. Just leave that road map there. 12 is carbon, and there's only one, so we add 12 once. 16 is oxygen, and there's 2 16s there. So we're going to add 16 twice. Kind of messing my little order up there. What does that end up being? 44. Actually ends up being 44. Okay, 44 grams per 1 mole of CO2. So that's how much CO2 is in that 46 grams. Now, if we calculated it right here, you would end up with the units of moles, and that would give you how many moles of CO2 that is, which is a perfectly reasonable number. But we're going to go one more step further, and we're going to say, okay, we want to know how many moles of glucose that is, right? So you need the molar ratio. Here we are. So let's go here, and it looks like for every 2 moles of CO2, 1 mole of glucose is needed. Okay, so put the 2 moles of CO2 on bottom because we want to get rid of those units, and put the moles of the glucose, maybe I'll just say C6H12, put that on top. And then if we calculated this would give us moles of glucose. Okay, but we want to go one step further, and we want to get to grams of glucose. We want to get to Gramville, the mass, right? Sure, we need the molar mass, but luckily we already calculated it, right? Remember it was 180? So for 1 mole of C6H12O6, it was 180 grams of glucose. Don't forget, that had to be the glucose molar mass, not anybody else's molar mass, because then we wouldn't be calculating it if we didn't have, if we were using something else. Okay, so now we want to multiply the tops. And that's 46 times 180. That's a big number. But then we divide by 44 and divide by 2. And I already did that calculation, and you should get 94.1. You can only report the 0.1 though, because it's significant figures, if you had more than 2 significant figures in your weight. So if your weight was really accurate, then you could report more digits. Okay, so otherwise we get 94 grams of glucose, and that's how you do those problems. C6H12O6. Okay, so I'm gonna have a worksheet for you to do. That's gonna either give you formula, yeah, and you may have to balance it, but then you should be able to go from grams to moles, maybe to grams, or moles to grams, and we'll try to keep this roadmap in mind when calculating these, and you may need to calculate some molar masses, but we all remember how to do that, right? Okay, if you don't remember, let me know, ask me questions, private message me, and we'll talk, okay? Hope you're having a great day, and we'll talk to you later. Good night.